AI is that statistical models are very good at defining similarities between data points, but the meaning is not grounded anywhere. So symbol grounding is actually something that we have already discussed, but it's really a key problem if we want to achieve AGI. And that's not easy to solve because even when you pick up an English dictionary, for example, it's not like you have real definitions there. It's always, sometimes, most of the times, you have this loop where something is defined in terms of something else and vice versa. So, for example, if you want to know what it means to buy something, in most dictionary, you find that it's the thing that you do with money. And but then what is money? Money is the thing that you use to buy stuff. So that's the problem with language in general. It's what, as we discussed in one of the lectures, is just one way that we use to communicate with each other. Maybe if we could communicate with each other using telepathy, well, then we wouldn't even need a language. But some say that language is still very important for us to reason in general. So even when you're not talking to anybody, but you're just thinking, you're still using language to formulate and put together your thoughts. So even here, there are different opinions and different school of thoughts. But then, yeah, it's important to understand this concept. All these models that we work with, from large language model, but even naive Bayes classifiers and bag of words models, are based on the assumption that we know already the meaning of a word like lion. But the sad truth, something that we don't truly um, think about all the times, is that there is nothing in the word lion that actually resembles a lion. If you're taking an icon or something else, then maybe you could claim that. But there is absolutely nothing in the word lion that resemble a lion. These are just four letters that I put together, which in English they replicate a sound, lion, that we learned how to associate to the concept of lion. When and how? In the first years of our lives, by brute force. This is the important bit. There's nothing that connects explicitly these four letters to the concept of lion. We just had to learn by brute force that whenever I have these four words that resemble the sound of lion, then I'm referring to this animal. So this should make you think of what really means for a large language model to reason and to think, because then if you don't have this grounding, this connection, then yes, you can ask a large language model what a lion is, but it's not like it has an internal representation of a lion. It just uses some other documents in which, like for example, some Wikipedia page that defines lion, and that's it. It's a bit like uh, as much as a colorblind person understands colors. Yes, they understand the differences in a very high level manner, but since they have never seen it or experienced it, then you can't really grasp all the different nuances. And this is one of the problems of AI today. So because large language models are trained on documents, we usually don't explain common sense in documents. So, for example, throughout this whole course, I didn't have to explain some of the basic concepts that we all take for granted. I never had to say, I never, for example, had to specify the difference between a human and a machine, although we actually did talk about that. But there are many things that are commonsensical, and there are many different kinds of common sense, from spatial common sense to other kinds of common sense. And this is one of the things that is lacking today. So yes, some people claim that large language models do have common sense, and I don't disagree with that. They do have some degree of common sense, but then um, it's a mistake to claim that they understand the world the same way we do, and they have the same common sense that we have. So this is something that people have been working on for many years. As I mentioned in one of the days before, Doug Lennart was one of the first to work on this, but also Marvin Minsky was talking about common sense. But Doug Lennart was the one that even before the year 2000, I think, was trying to build the first common sense knowledge base. It was a bit too formal, psych. It never took off, but then that was historically the maybe one of the first attempts. So common sense is a bit like metaphor. Like we use common sense to understand things much more than we realize. So common sense goes from things like affordances to size to compositionality, typicality, location, and many more. These are all things that we just know because after growing up, you learn all these things, but and then they're kind of embedded in us, unconsciously part of us. But then, if you don't have these things written in text, then it's virtually impossible for a large language model to learn some of these things, or at least to grasp the full meaning of these things. And again, we think, okay, maybe you don't really need common sense that much when you're doing natural language processing, but actually many sentences, and if not all sentences, require common sense. The only problem is that we don't realize that we need so much common sense reasoning because we do it in such a easy and unconscious way that we don't realize actually that we are using common sense. If you take a sentence like this, I saw the Colosseum flying from Rome to Genoa, I immediately picture what's happening. I was probably on a plane, and as I was flying from Rome to Genoa, I saw the Colosseum. Never we thought that it was the Colosseum that was flying, that was taking off. Why? Because our common sense tells us that big objects and especially monuments cannot fly. And so you may say, okay, but this is maybe a very specific or special example. Actually, we really use common sense in almost every sentence. Let's take a much simpler sentence like this. I saw a kid with the cat. So when an AI model needs to model a sentence like this, it's doing it can do it in many different ways depending on what is the final downstream task. But in general, when you're trying to understand the sentence, you do what? You do something similar to text chunking or dependency parsing. So, and this is the thing that we also all think. Like the moment we read this sentence, this is what we thought immediately. We didn't think of anything else, but actually unconsciously we didn't need to do any of this because of our common sense. But a natural language processing tool or an AI model maybe doesn't have this luxury and need to really disambiguate each word in this sentence, or even every possible meaning that this sentence may have. That's why, again, and now many AI researchers are working on chain of thought and tree of thoughts to really have multiple versions of the same understanding in parallel, and then choose the one that makes more sense maybe later when I have more information about the current scenario. And so I'm talking about things like the preposition with actually can be very ambiguous. We never thought of these when we read this sentence. If I say that I saw a kid with the cat, it must mean that I saw a kid that was holding a cat. But in theory, this could be also an option. With the cat, it doesn't specify that it's the kid that has the cat. I could be the one holding the cat. with, as you know, is also used as an instrument. I never thought of this option that I would use the cat as an instrument to see. But if you don't have common sense or an ontology or something that tells you that the cat is an animal and not an instrument, then this could also be a plausible possibility. Then, as you know, so in English can also have another meaning. It's not just the past tense of seeing. And so this could also have been an option. We never really thought about this unless you're a psycho. But yeah, there are many options, many possible scenarios that could be potentially true from a linguistic point of view. But if you have enough common sense, you don't even think about all these possibilities. But this example is still powerful to state that we need common sense much more than we actually realize. So it's all with all this in mind, we built our own common sense knowledge base. Actually, we first started with SentiCnet, which was also a common sense knowledge base because it's based on ConceptNet, which is a common sense knowledge base built by MIT Media Lab. But then we also wanted to have a more specific knowledge base that is really focusing mostly on, um, in general, more general common sense rather than just specific to emotion extraction. So this is something that I have just a few slides on this, but you can also look this up, and it's also free to use and downloadable. And the way this works is similar to what I mentioned before in terms of having this hierarchical structure where you have entities, concepts, and primitives. And so here, another thing that maybe it's useful to mention is that, and then I didn't clarify earlier when there was that question by Vivek, is that the definition of a primitive or even a super primitive, it really much depends on what you're doing. So, for example, in a situation like this, when I'm trying to generalize, to build a common sense knowledge base that supposedly encompasses everything, uh, I still have to set a limit to where I'm going to stop. For some primitives, because here, for example, a lot of the knowledge that you have here is about tools and things that you can use, like physical objects. And if I use a technique like the one that we mentioned earlier, that I just follow all the is a links, and I only consider those concepts that are only receiving is a link, then maybe I'll have that everything is connected to the same primitive, and this is maybe a super general primitive, like a thing. Everything is a thing. If I use thousands or billions of documents to do this, then maybe when I generalize, everything becomes a thing. So that's why I have to stop somewhere. In this case, we choose that, for example, when I'm talking about physical objects, I have to stop maybe one step before the more general thing. And in this case, that's why a hammer as a final primitive has a tool. So there will be many other concepts, many other tools like screwdriver and all the possible types of screwdriver that are also linked to the primitive tool, and then it stops there. So in PrimeNet, we used quite a big set of relationships. So as I mentioned, there are some projects like Probase, for example, by Microsoft, that only uses the is a relationship, and ConceptNet from MIT Media Lab uses about 20, if I'm not wrong. We use 34 different relationships to have a more fine-grained understanding of how different concepts in PrimeNet are connected. The concepts, once again, are words or multi-word expressions that are linked by property. So this is a good example of a semantic network. So once again, the difference between a neural network and a semantic network is what? In a neural network, those edges that connect the nodes in a neural networks are numbers. That's why it's called sub-symbolic AI. We're not using symbols, but in the case of a semantic network like this, we are using symbols. We are using relationship in English to define the relationship between nodes and concepts. And Primate also uses the mechanism that I discussed earlier about the generalization into primitives. And here, once again, we have to stop at some specific primitives based on the specific topic. So this is, once again, not a static definition of primitive, but the final goal is the same. We want to be able to generalize all the possible ways to specify something in English so that we have a more compact and meaningful representation of the meaning. So here, yes, you have an example of the whole many of the possible ways of expressing that the device, the temperature of a device has gone up. And in the paper, if you are interested, you can also, but also in the book, you have some of these, you have more details on how PrimeNet has been built and also some comparative evaluation with other available common sense knowledge bases like ConceptNet, Atomic, and CSKG. So all these, again, to have a framework that can do different kinds of reasoning. And this is very much cognitive inspired because supposedly that's also how we go about our daily tasks and reasoning every day. We have two different systems as suggested by neuroscience, and they are called in different ways. There is some call it uh, right brain, left brain, system one, system two, fast thinking versus slow thinking. But it's been proved by using, like, for example, fMRI, that we really shift to two different kinds of thinking depending on what is the task at hand, and maybe even for the same task, for all the different parts of one task, we can shift in between and these two. So by fast thinking, I'm talking about intuition, or something that you can blurb out or generate very quickly using, for example, a large language model. System two, slow thinking, is something more methodical, like in a semantic neural network, or using logic, or using another scale model that can have a representation of, for example, of a mathematical problem. And this is a much more powerful way to do things rather than just attempting to intuitively solve everything and automatically generate everything. Why? Because as we discussed, large language models, no matter how good, they still suffer from hallucination, because in some cases it's not the right approach is not to statistically generate an answer, but it's really going through some specific reasoning steps. And that's why, again, some people now are working on chain of thought. So even though they're still using large language models only, they still force the large language model to go through some specific reasoning steps. So it's supposedly more accurate, or at least more interpretable. And in the book or in the paper of PrimeNet, you also find more examples of how and where common sense reasoning can be helpful, especially for multimodal reasoning. And we also have some papers in which we look at many different properties of large language models. So we also have some papers that are purely statistical and only focus on large language models. And some, for example, we try to find out what is the bias of some large language models. In this specific work, we look at how to evaluate large language models, especially in terms of things like error analysis and robustness, because then once again, it's not just a matter of getting something correct or accurate, it's also a matter of robustness. So if I ask the large language model multiple times the same question, do I get the same or a similar answer? Is also the LLM robust enough to be strong, in case I say that something is wrong, but it's actually true? Is the large language model able to counter that? In many cases, it's not. If I correct a large language model, in most cases, even if it's correct, it will say, "Oh, I'm sorry, you're right. It should be the way you say it." But then it should have some sort of beliefs or ways to actually check whether something is correct or not, and also implement different kinds of reasoning that are not just inductive, how more statistical methods are, but also deductive and abductive. So I want to conclude with some discussions about how we can use AI, how to um, put ourselves in relationship with AI. So if you're in academia, definitely you are in the right environment to learn more about AI, but you also need to be very much open-minded, because in the past it wasn't really like that. In the past, the job of a researcher, or even a professor, was so much easier, because you just had to learn something very well and then you could just work on it for the rest of your career. My PhD supervisor did exactly that. I mean, now he's still trying to reinvent himself, but still, if you were a professor 10 years ago, you could just be teaching SVM and fit forward network for the longest time. But now you really need to look out for whatever is coming out, and try to keep up with it, which is not always easy. But if you're in academia, that shouldn't be a problem if you are exposed enough to novelties and different papers. But then you may also have the opposite problem of having too much information, too many papers to read, and so on. So you need to find the trade-off. But the problem is also for businesses that want to adopt AI, but they don't know how, they don't know where and how. So one of the problems actually is not so much about the money involved, but actually the lack of expertise. Now, the biggest problem that most so-called AI companies have is that they don't have enough AI talents. So that's actually good for you, for those of you who are still looking for their path and a job in academia or in business. But then, yeah, it's also important to keep ourselves updated. So, with all this in mind, I was invited by some people at IEEE SSCI to define some sort of roadmap for companies on how to adopt AI. So this is a short paper that's going to be presented at the end of this month in Norway, and can actually be useful for all of you. Like yesterday, I remember talking to some of you who are just linguists and they don't know AI yet. So how can they and start learning about AI if you're not a computer scientist, or if you just started and you're a junior computer scientist that wants to learn more about AI? So the first step is definitely to use something that is already available out there. It's even something as simple as using ChatGPT, or some APIs like the ones that we provide, Centric APIs for affective computing, and then be able to interpret results. So the first step is definitely to use someone else's AI. You don't have to obsess too much on building your own if the ones that are already freely available or even commercial off the shelf are good enough for you. And that's a mistake that many companies make because they are so obsessed with building their own models that then they don't realize that maybe there are some models that are already available and are already good enough, if not better, than the models that are trying to build. But if you do want to build your own model, then it's important to build something that is as interpretable as possible. I mean, that should be the thing that drives you to uh, to build your own model. So if you're building your own large language model, you want again to have some sort of mechanisms there to make sure that you can interpret, understand how your large language model come up with specific answers, what kind of reasoning steps it's doing, or if you provide more than one reasoning strategy, when is the LLM switching between one and another strategy. So, and once again, when I talk about interpretability, I talk about as an engineer understanding what's inside your model, understanding how your model works and why you get this kind of answer when you use this training data set instead of the other. So once you have this, then you can build the explainability on top of this, because now many are working on XAI or explainable AI, but they're just happy to have some sort of explanation. And that's a mistake, because an explanation is what? It's just a piece of text that can be also automatically generated. But then who tells me that this explanation is good or bad? The explanation, in theory, should be built on the interpretability. So if you have some internal parameters or variables that can tell you how your system work, then you can use this interpretability to build explanations on top, give some very detailed explanations of why things are happening, why your LLM or your AI model in general is producing that specific output. The next phase, which is not what many are doing, is to actually evaluate those explanations. So once again, many of us AI researchers are now finally looking at or working on XAI, but again, they're happy enough to have explanations. But then the big question once again is, how good are these explanations? We evaluate explanations based on utility, robustness, and faithfulness. This is not so straightforward, because you have to think that explanations are not really a label like positive versus negative, right? They can be expressed in so many different ways, and it's so much more difficult, even subjective, to state whether an explanation is good or bad. That's why you have to come up with some sort of framework. And that's what we did by by looking at utility. So how useful the explanation is, because I can generate an explanation that is completely useless, then what's the use of that? Robustness, again, if I keep asking my model, do I always get the same explanation or not? And finally, faithfulness. I want an explanation that is faithful to the model, that uses the interpretability to give me a faithful explanation, rather than just randomly generate an explanation that is, yes, plausible, but maybe not based on actual data. And you could call all this trust, because then once you have explanations and evaluation of explanations, you can finally have a system that you can trust. What's the last step is to have a model that is also interactive. So once I have this model that is interpretable, explainable, and I can also gauge how good the explanations are, then can I interact with it and change the output based on my preference, on my liking? So to give you an example, if I'm doing financial forecasting and I get a result with some explanation, I don't like the explanation. I don't like some of how the results are calculated, because then maybe if I ask the system tells me that he used this training data from this historical period, then an interactive AI or human AI is an AI that I can interact with and say, look, I don't like this part. I don't like that you're using this part of the training data. Leave that out and redo the calculation. So this kind of interaction is where it's really powerful, because an AI, once again, doesn't have eyes and cannot see the world the way we do. And the real power will come when we have this synergy between humans and AI. This is also to stress once again that even though the AI revolution can be scary for some, because some jobs are being lost and then will be lost, there will be definitely room for so many more. In this final few slides, I also want to discuss about some problems that maybe you guys may have as you start using AI, or in general, when you take a supervised approach, even using an SVM or naive Bayes classifier. It's important to make sure that your training data is good enough. So as we discussed, an AI model is only as good as the training data, right? So you have to be sure that it's comprehensive enough, that it's covering all the possible stuff that you're trying to learn. So if I'm doing sentiment analysis and I'm a company that provides different services or products, then I want to make sure that all my products are covered in the training data, possibly in the same amount. We'll talk about this in the next slide. But I also want to have some information about my competitors' products if I want to have a big enough view of what's happening in the market. And anything that is also similar, like dupes, I also want to have them in my training data if I want to have a more holistic view. Because once again, it's not like the system can invent classifications about things that it has never seen. And as we discuss many times when we mention aspect extraction and aspect-based sentiment analysis, for each of these three, you also want to have not just general information about the product alone, but all the possible features or aspects of each of these products and services. So in the case of product services, it's clear what an aspect is, but aspect also can be all the different parts of even if you're talking about a person, like even if you're talking about politician, because you're doing political forecasting, then you can still break down a person into all the things that are important for that specific domain, like the way people talk, the ideas that they convey, the sound of their voice. All these things are aspects that can really give you a finer grain insights of what people like and dislike about your product or service. Then, as I mentioned, we have a lot of works on bias. We realize that actually LLMs are very much biased. And if you're building your own system from scratch, you also need to make sure that bias is not there. You need to try your best to have at least a training data that contains equal, that is balanced. And we'll see that in the next slide. So if I like this relates back to the example that we did of the AI that was skewed towards selecting candidates for a job that they were male. And that was mostly because much of the training data was about successful male candidates. So you don't want that. And the same problem you have with races, where they they had this big problem. The first computer vision tools were able to better recognize people from a certain race rather than others, because they were mostly trained only with people from that race. So you have to make sure that your training data is as unbiased as possible. There are other issues like privacy, making sure that your data is not recognizable to the actual user if you're if you're working with users. And one simple way to do this, instead of providing the actual data, you can just provide an embedding. So once you represent a user in a vector space model, and this data point is defined not with the name and surname of the user, but just simply as user 1, 2, 3, then that's one simple way of doing um, data cleansing, but that there are much more sophisticated ways to make sure that the privacy of user is respected. This is actually also a matter of debate on, like, for example, all these large language models that they just absorb all this information from the web. It's always a question of whether these contents were um, too private or they were infringing any copyright. So these are things that still needs to be discussed and identified. But in our case, if let's say we're just doing sentiment analysis, maybe the most important thing to do is to make sure that our data is balanced. So it's very hard, if not impossible, to have data that is perfectly balanced, because then you have so many different facets of your data. Like, for example, we mentioned earlier, you have gender, you have race, you have age. It's impossible to have an exact number for each of these categories, but at least knowing where the ideal situation is and trying your best to achieve that or get as close as possible to that ideal situation, it's really important. And this again sounds very trivial, but I'm telling you, this is the most common mistake that most companies I work with do. So, for example, if they are building their own sentiment analysis tool for market research, they just dump in all the data that they have about their products and their customers without even checking how much of this is negative and how much of this is positive. Then suddenly, even if they use the best available AI model, they'll get a very skewed output where most of the text, new text that they try to classify is negative. Guess what? Because then maybe they had like 80% of the training data was negative and only 20 or less was positive. So having this in mind and trying your best to fix this, it's extremely important. Again, it's impossible to have perfectly balanced data, but trying your best to fix this and to have something that is a bit more balanced is important. So in this slide, I have a simple example that is more practical to understand this problem. So let's say that I'm looking at social media and I collected 1,000 tweets that are relevant to my investigation. So in theory, if I'm doing sentiment analysis on this polarity detection, half of this should be objective or neutral, so that I can first use, for example, a subjectivity detection module to filter out the ones that are neutral. This is an important task once again. So having something that is well trained to recognize neutral data is important, and that's why you have half of the training data neutral and half subjective. Then subjective means what? Subjective data is some positive, some negative, once again, and ideally I would like to have half of these 1,000. Maybe 250 are positive and 250 are negative. And then if I'm looking at aspects, I want to have the same amount of tweets for each aspect. So if I have 5 aspects, I would want to have 100 tweets for each aspect, ideally. And then, of course, for each of these aspects, I would want to have 50 positive and 50 negative. Of course, as I mentioned, having something like exactly like this is impossible, but at least making sure that you don't have more than 80% labels in your training data that are of one class instead of the other, it's quite important to have a system that works. These final few slides are some consideration on what could be the jobs of the future, and it's hard to tell, but definitely all the things that can be automatized and they are mostly textual are highly probable that will be replaced by AI. I forgot who said this, but maybe one way to put this is that if your job is solely about typing on a keyboard, then maybe your job will be replaced. So it needs to be more than that. So as I said in one of the first lectures, what's interesting about this revolution is that for the first time, it's the white collar jobs that are at risk. The blue collars are very stable because we're still far from having robots that can do plumbing and other things that we still need and will probably need more in the future with the aging population. But then, yeah, your job should be definitely every job now. Most jobs they require using a keyboard and a computer, but it should be more than that. It should be more than just about producing text. So even when you take something like writing a research article, what will be more important in the future is the novelty and the idea of the article. Maybe in the past this was as important as it is now. In fact, I still remember when I was like the job of a reviewer or associate editor in the past was so much easier because you could tell straight away whether a paper was good or bad based on how it was written. But now you don't have that luxury anymore. Some papers that are completely empty and not novel are actually written in a very good English, probably by ChatGPT, and it takes much more time to understand whether a paper is good or bad. So this just to make you think of the things that you should be focusing on for your future career if you are at the beginning of your career. And so here is there's a few jobs that have more maybe more potential or more demand at the moment in the context of AI. And but definitely, if you go for an AI interview, you need to be aware of many more things than just the technical aspects, as we discussed in this workshop. AI is very multidisciplinary, so it's important to know all the things that need to be automatized or integrated in AI so that you have more chances to nail to get that the dream job. But in general, my belief is that as we move forward, this integration, this synergy between humans and AI will be more and more important. I don't believe in completely automatic systems that will be doing everything on their own, or even these apocalyptic visions where man, it's not an apocalyptic vision, but an extreme vision where the AI machines will be doing everything and we'll be just doing nothing with our lives and just dedicate ourselves to hobbies because machines will be doing all the work and so on. So before I conclude, I just want to give you some insights of some of the research that we do. So this course was more in general about AI and data representation and classification. But what we do in my lab is mostly affective computing and sentiment analysis. You can check some of our works in this department of IEEE Intelligent Systems. And in fact, if any of you is also working on these topics, we are always looking for articles for this department. This is a very special department because the articles are rather short, just 8 pages. So it's a bit more like a conference paper, but it's actually published as a journal article in IEEE Intelligence Systems, which historically is one of the good, if not one of the best AI journals. And here I want to talk a bit about emotion categorization, because in our case it's very important to just not to simply use statistical models to do emotion detection, but really look at the historically which emotion detection models have been proposed, and which is the best for which specific domains. So here you have a few examples. The one that I mentioned earlier is the OCC model by Andrew Ortoni. And then there is the Ekman emotion model, which focuses on six emotions, mostly for the visual part. And then you have Plachik. So one question here could be like, why do we have so many emotion categorization models? The reason are basically two. First, that there is no consensus yet on what is an emotion, or even like a basic emotion. And second, different models are better for different domains or modality. Like a good example for this, as I just mentioned, is Ekman. Is a rather limited and simple model, only six emotions, but still works very well for multimodal data, for categorizing facial expressions. And so we also try to come up with our own model for emotion recognition from text. This was the first model proposed in 2012. And then I think 8 years later, we had the revisited version of the hourglass model. So we fixed some problems, like the fact that there were some uncanny color associations. So now we studied more the literature of which color should be associated to each emotion. So this was mostly just a revisitation of Plachik or Pluchik. Some people pronounce it differently, but we just took the emotions from the wheel of emotions of Pluchik and reorganized them. But then we realized that we also needed to do some tweaks, like, for example, changing the colors, but also doing other things like having this mirroring of positive versus negative emotion. And this is a very useful thing to have, because in all those cases in which you have to negate or reverse the emotion, you can just look at the mirroring on the other side to understand what's the opposite emotion. And that was not so easy to do, because then it's while it's very easy for joy versus sadness, it's not so much for other emotions. Like, for example, there's not really a consensus on what is the opposite of the emotion of fear, for example. Also, many, if not all, the other emotion categorization models didn't have calmness, didn't have anything to oppose to the emotion of anger. So we did all these to have a better way of working with emotions. So this is what I just mentioned. Like in Plutchik wheels of emotion, for example, you have that fear and anger are opposite to each other, but that's not the way it should be. And so that's why we also introduced these new emotions that you don't have in any other emotion model. This also came from ideas and discussions that I had with Andrew Ortoni himself. He was the one to propose that an emotion model, should have calmness. And then what else? We also have special versions of these emotions to also map self-conscious or moral emotions that once again are missing from other emotion categorization models. So for these, we use this specific dimension, the dimension delight versus disgust, pleasantness versus disgust. So we use these same emotions. Once you direct these emotions towards yourself, that's when you have those self-conscious emotion. And when you feel these things towards others, then these are more like moral emotions. And last but not least, also this also came from a discussion with Andrew Ortoni, who is a firm believer that surprise is not an emotion. In Ekman, you have surprise as one of the six emotions, basic emotions, but Ortoni believes that surprise is not an emotion. Many others, not just him. We didn't want to get into the debate, but we did remove surprise from the model because surprise per se is neither positive or negative. It's only when it's um, in concomitance with another either positive or negative emotions that then it generates a polarity. And so we also fixed the formula to calculate polarity based on emotions. This was the old polarity definition that didn't work so well, so we came up with a new one. So if you want to know more details about this, you can read the paper and see how this works, or just use our Centi KPIs, which are based on this model. So to conclude, I just want to share with you some of the works that we are currently focusing on. These are our 7 research umbrellas. As I mentioned just now, we work a lot on explainability, specifically for sentiment analysis. So we look at how to evaluate sentiment analysis explanations in terms of utility, robustness, and faithfulness. And then we also work a lot on personalization. I already mentioned this. We look at all the different layers of user profiling that we can do and use those to perform sentiment analysis. This, again, it's very important, as I mentioned the other day, yesterday, when I was talking about personality recognition. There are some pieces of text that are neither positive or negative. They only become positive or negative once you know what's the personality of the speaker or the personal preferences. And then we also work on different modalities, as I mentioned. Mostly we focus on text, that's true, but we also have a lot of works that look at video and speech. And some of our recent works are on vision language models, but also multimodal sarcasm detection, and so on. And these are extremely interesting works because it's not just about having a good classifier for each modality, but then also deciding how to fuse the data and to do the final classification. This is still a big question in multimodal analysis in general. Some adopt an early fusion, some a late fusion, some simply represent the data from different modalities as embeddings, and then they simply concatenate the embeddings. And so, and others do so much more. So it depends on, again, what kind of data and domain you're working with. We also work a lot on different languages. So we have some works on different languages. We don't have much on Indian languages, so we can, maybe we have few works with Asif, but that's pretty much about it. But yeah, we have some more recent works that look at multilingual analysis from a broader perspective. In this more recent work from last year, we do something very interesting, that it's more about cultural analysis rather than language analysis. So we use a special rotation to basically overlap two representations of the same concept in two different languages. And then to fix them together, we use some sort of anchor concepts, which are very concrete and unambiguous concepts. So basically, if you think that, for example, this space is the English space, and this is the same space in, for example, in Hindi, of the same words, but in Hindi, then if I overlap them together and fix them together using those very concrete and unambiguous concepts, then I can also look at the difference, the semantic variations between other concepts that are more abstract or more ambiguous. So you can also see using this what are maybe the cultural differences between two places, two countries, two cultures that use these two different languages based on what? Based on the distance or cosine similarity of these other concepts that are more abstract or ambiguous. So this is something that could be also very interesting for a linguist, for example. And we also work a lot on multitask. I mentioned many times how we use multitask learning for different tasks. One of the first works was done by Sujanya for sarcasm detection. So we were looking at sarcasm plus polarity detection in a multitask framework. And more recently, we have this work where we look at all those modules from the syntactics layer of the suitcase model, and we put them all together using a multitask and curriculum learning architecture. And we also work a lot recently on financial sentiment analysis. So we look at many different kinds of data coming from social media and financial report, but not only text, we also look at numerical data, technical analysis, and then here, as we said earlier, for the multimodal sentiment analysis, also a matter on how to fuse these effectively and also make them all explainable. We also worked a lot on dialogue systems, and here, instead of just having a dialogue system that answer questions, we also look at emotion-aware dialogue system. We look at how the user sentiment and emotions are evolving throughout the conversation. So these works were mostly about uh, not just about detection, but also in a time series looking at how the conversation evolves through times, what kind of emotions are involved, what kind of intensity you have. So you can look at this if you are interested in this kind of topics. And in general, you can find more information at this page. All these papers that I mentioned and many more are freely downloadable on this page. To conclude, I also want to list a few of the projects that we're currently working on. Obviously, working on sentiment analysis, we use a lot of these for business intelligence. We have some recent works on socially responsible investing, but also corporate sustainability. So if you're interested in these topics, you can take a look at those. We also have, of course, social media monitoring. We have several projects. More recently, the one that we are more focusing on is about climate change mitigation. So understanding how people perceive different aspects of climate change, which can be useful, for example, for policy making. We use also AI for education. This is a paper from last year in which we use a vision language model to measure engagement of students. And then we use AI for social good, looking at different phenomena like the Me Too movement, but also LGBTQ community, and understanding, for example, also what are the problems, the cyber issues at stake. We use AI for healthcare. This is an example here, this paper, Mega Care from 2 years ago, but more recently, we're focusing on mental health applications, as I mentioned several times during this workshop. We have several works on explainable depression detection and also suicidal ideation detection. So anybody working on these topics is very welcome to work with us. And then we also look at things like toxicity. So in this work that is a bit more dated, We also look at how to identify toxicity and then classify toxicity according to different categories of toxicity. And last but not least, also intensity of toxicity, which can be useful for countering phenomena like cyberbullying or cyber harassment. And last but not least, as I mentioned, and when I was talking about multidisciplinarity in the seven pillars for the future of AI, also the arts. We have some works when in collaboration with our colleagues from the School of Art, and this is an example here in NTU. We have this arch that displays different emotions in different colors depending on who goes through the arch. So if you are interested in this, you can also check this link. There are multiple links to different works on this page. And to conclude, I also want to share some possible venues for your next paper. You have all these links in the slides. This is an open call for papers. It's a special section on cognitive computation, which is always open, specifically about Centric computing. So if you're using CenticNet, Affective Space, or PrimeNet, or whatever, you can definitely submit here. But even if you're just publishing something related to affective computing, it's also fine to send it here. And then, as I mentioned, we have this book series by Springer on social affective computing. So anyone who has enough papers on this topic and wants to put them together in a book or even convert a PhD thesis in a book, you can also contact me about this. Me and my PhD supervisor are the editors of this book series. You can also contact him. And then there are some call for papers for some special issues coming up in some journals. This is the one coming soon for IEEE intelligent systems. And then there's one that has deadline much later this year on Nature, on neuro, specifically on Symbolic AI. And then, as every year, we have the Sentire workshop in ICDM. Last year, we were in Abu Dhabi. This year, we'll be in Washington, D.C. So what's good about this workshop is that the proceedings are published everywhere, Scopus and also Web of Science, which is not so common for a workshop. And also a good thing about this is that you can actually just submit to the main conference, to ICDM, by 6th June and select Sentire as the workshop. So in case your paper gets rejected by the main conference, can be redirected to the workshop in an instant. For those of you who wants to keep yourself updated with what we do with some research on affective computing and sentiment analysis, you can follow this YouTube channel. There are several videos. Some are a bit longer, but mostly they are like just 5 minute videos that's nicely summarize some of the papers that we have published recently. And last but not least, if you're working in some of these topics, don't forget that you have a lot of free resources on our website on centric.net/downloads. You have all these resources in so many different languages, including also, I believe, some Indian languages. And there is a lot of code, a lot of repositories, 60 plus repositories that you can download for free on our website for some of the tasks that we discussed. For example, here you have a repository about personality detection, one about multimodal sentiment detection, concept parsing, and so on. And then, again, if you don't want to download any resource or any code, you can also simply just subscribe to our APIs, which are free to use. And so you have many things that you can do with these. There's also a user interface where you can visually see the results of your analysis on this sort of mini vector space model that you get as a result of your input. You get some concepts, some key concepts. Then here you have the classification label and intensity, some emotion labels based on the hourglass model, together also with the intensity of emotions, aspect extraction, and personality prediction, and so on. So that pretty much concludes today's lecture and the workshop. I went a bit over time, but I hope it's fine. I'm still happy to take any questions if there are any. Yeah, I see a question from Vivek.
So if none of them are having questions, actually, I wish to have one opinion from you.
Sure.
Definitely, this topic has left me amazed. The integration is nothing short of brilliant. I was actually feeling how beautifully everything has been brought together. So,
Thanks. It took many years of fine tuning and also a lot of help from my team. So one advice that I also want to give to all of you is that there's only so much that you can do on your own. You really need to find the right person to work with, and that includes not only the people that are working for you, but also your collaborators around the world. And as if is an example of that, we have published quite a lot of papers in top journals, and I wouldn't have been able to do that without his help. So that's just a small token of advice for all of you. But please go ahead with your question.
okay, so I was kind of wondering that we have, so if we talk about LLM,
Hmm.
these are quite powerful and very analytical and statistical approaches are there. And then symbolic system is kind of providing us with the reasoning support. Then comes the language's own grammar. Like for example, in the coming days, uh, scholars are working on lexical functional grammar or head-driven phrase structure grammar. Those are the new and the complex theoretical superstructures which they are building upon the lexical items. So I was willing to have your opinion that do we really need those theoretical superstructures from the grammatical frameworks which they are working when we have so much sufficient work done in the AI thing? Do you see any integration or any opposition, or do you see substitution of grammatical framework totally by this?
Yeah, it's a good question because now it's a bit confusing because some say that we need very strong fundamentals and theoretical frameworks, and while many others say we don't need those. We just have to have a good statistical model, throw in as much data as we can, and we'll get the results that we need. But again, it boils down to what you need these models for and what's your final goal. Some people goals is to understand how the brain works and try to emulate intelligence into a machine. That's why I'm more interested in the theoretical part. Some others are, if you only care about having something that has high accuracy, then you don't care too much about the theoretical framework. But then there are also cases where, for example, you need something that goes beyond statistics, and in that case, you have no choice but to have a theoretical framework. It's a bit like it's happening also in business now, where maybe too many businesses are a bit too obsessed with AI. Like it's not a good idea just AI everything, or they say like AI or die. It's AI needs to be used only for those specific processes in a company where you need to automatize. So the same goes with all these different approaches and definitions of AI. It really depends on what's your final goal. So I agree with both of these people. So I like those that are happy enough to use large language models because maybe they're only focusing on a maybe simpler classification problem that only requires a high accuracy, and then they rightfully say who cares about the theoretical framework. And on the other hand, those that say no, our goal is to build a theoretical model, a cognitive architecture, so that we can have maybe better interpretability and explainability, they are also right. And in fact, if you look at our papers, you will see a mix of both. There are some papers that are very technical, and they are just using statistical models to do pattern recognition and classification. And there are others that are instead much more multidisciplinary, that they look at cognition, they look at implicit analysis. And for those, you definitely need a more theoretical framework.
Thank you. That was kind of that helped me to understand what things can be placed where. One last question I have, just last question.
Mhm.
Uh, so you were talking about those emotional mapping where you had this R factor. I guess that was a matrix which can convert one plane of emotions to another plane of emotion, which is in another language, I guess. So you used the word target language, right?
The multilingual analysis, you mean?
Yeah.
Yes, okay. Let me get to the slide.
So yeah, this one. So from the semantic space of English to the semantic space of target language. So now, if we have this kind of a situation, we can think English not as a target language, but a meta language, which all research can be done, and we don't really need any research on the target language side. Do you think that in doing any work on choosing one particular language and trying to say that we are developing AI tools for one particular language, that is not really helpful or a requirement of the current time?
Uh, uh, no, so there are many that say that we don't need to do multilingual analysis. We just need a good machine translation tool that translates all languages to English, and then we just work on English. But this work shows exactly that it's not true, because then even if you translate words from a language to another, the way these words are represented in different languages are different because of the training data, and ultimately how these concepts are perceived in different cultures. So I don't have a good example for Indian culture, but for example, and something that we realized is that the concept of dragon, for example, is very positive in Chinese or Asian culture, but very negative in European culture. If you see all those old paintings, is always about slaying the dragon. So this is exactly why we need multicultural and multilingual analysis. And that's why, as I mentioned a few days back, we are working on building a large language model for each different Asian language. Again, it's called Sea Lion, Southeast Asian language in one network. And that's not because we don't have good machine translation tools, but because we believe that every language has their own nuances, their own common sense, their own culture that needs to be encoded separately. It's not fair to just use some sort of mapping. You're right. This work should could also be used to perform some sort of mapping of any language to English to then just work on English. But I wouldn't recommend that. That's not what this work is for. This work is really to understand the semantic, if not cultural, differences between languages, between concepts in different languages. But that's also why we need the help of people that are not computer scientists and linguists, but also people working on like sociologists that can tell us more about this kind of things, like what to look for, what kind of analysis to do. And so I think in the future, it's really important for us working on AI to be open-minded and curious enough to also look at other disciplines.
Okay, I guess that may be a requirement for some specific cases, because I was using ChatGPT for one particular reason. That was something I was
Mhm.
writing, and then I realized when I tried to get an answer in the Hindi language, what it did, it created or morphed a new word following the morphological rule of English, and applied for the Hindi
Uh,
language, and ended up in a very random word formation.
yeah, yeah. The way ChatGPT works, I believe, is using machine translation to convert every question in other languages to English and then convert it back to that language. But that's not really how it should be done because you lose a lot of nuances of the language and you may get an answer that is not is not good for the specific context. And this is also something that I mentioned a few days back when we were talking about the differences between ChatGPT and DeepSeek. They are very different from the way they were built. But besides that, you can see the difference because of the training data that has been used. ChatGPT tends to be more specific and good for anything that relates to US, while DeepSeek is better for things related to China. So that's also why we are building those large language models for Southeast Asian languages. Again, it's not just about the language, but also the culture and the common sense, the habits, and everything that they represent of us humans.
True that, and I'm so much thankful and grateful for the opportunity to learn from your experience. So I really thank you and IIT Patna for organizing and making us, means new people, as a part of
Yeah.
it.
Thanks. Thank you for all your good questions, and let's keep in touch. If you have any other questions, you can always
I have, but
contact me.
actually I don't want to kill your time. I'll drop you an email.
Yeah, yeah, sure. We can have a separate video call or discuss via email.
Sure. Thank you so much. I appreciate that.
No problem. Thanks for your questions. Okay, I guess.
So, Professor, just I shared like Vivek's enthusiasm because
Mm,
I'm from like industry. So we are so narrowly focused on like what goes viral on Twitter, like just transformer and everything. But this particular course, it gave us the context and the general history and possible directions of the field that maybe um machine learning or in that narrow aspect uh, is not maybe everything, and we can use some of the other approaches which were there earlier but are re-emerging, like um, neurosymbolic AI. So thank you so much for that.
yeah, I'm happy that you appreciate. So maybe some of you will not like too much this course because they were expecting something more detailed, more technical, but I believe that those are things that you guys can look on your own and also have to try on your own. And so that's why I thought it's better for me to tell you about the general methodology approach, so that even if tomorrow something new comes up, you know how to interpret, how to use, and how to integrate in your own tasks. So thanks for your comments. And again, any of you that wants to connect or ask questions later, always welcome too. I mean, if you also have like a specific problem that you're working on, I'm also happy to collaborate with you guys, or put you in touch with some of my team members so that you can work with them, we can publish together. I'm always open to this kind of collaboration. As I just mentioned, we have so many papers with Asif, so I hope we can have many more with the rest of you.
Yes. Hi, Eric. I'm Sunil.
Hi.
Uh, I'm also very interested in knowing to more about SME and medium industries,
Hmm.
because what we are struggling in, what we have seen in your slide, 2, 3 slides where you mentioned it. But those industry, even they want to adopt AI, but they don't know how to adapt and miss. What I feel is we are lacking to get the data
Hmm.
to change their process to you, so that they can use the AI in their daily to daily operation. To
Hmm.
be that is what I was looking to. So you have some general or something in that specific how to you mentioned AI to BI, that part. Small, if you have something more which you can elaborate it, and how can use it in the industry.
Yeah. So the first thing that I think an SME should do is to individuate
Yeah, this one.
um, where which parts of the processes of the SME need to be using AI, because once again, it's not like and that you have to convert everything to AI. And second, yes, understand which parts can be done using an external an outsourced AI, or even like a library that is already available. Because another mistake that many companies do is that they try to build something from scratch, and maybe they end up having a tool that is just average when they could have just bought something that is already available. But then, yeah, when you start building your own tools, it's important to understand, first of all the things that we discussed here about what is good training data. And then, yeah, also some companies are so obsessed with data that they even go as far as generating artificial data. But then again, it's something that it's tricky, because if you have even just a small error in the original data and you generate data out of this, then the error can propagate very fast, and you end up with very bad training data and ultimately a very bad AI model. But yeah, the important thing to do when you are like building your own AI model is to um, make sure that it's interpretable, so that you're able to understand whenever there are mistakes, whenever there are errors. You can do an error analysis to understand what are the weaknesses of your model. And also, if you have a model that is modular, so something like the suitcase model that we showed so many times, this allows you to do an ablation study. What is an ablation study? Is understanding when you remove some parts. Okay, I can't go back here. When you understanding what is the contribution of every module in your system to the overall quality of the output. If you have a general model, like a large language model, in which you just throw a lot of data, you don't have that luxury. But if you have something modular like this, you can do an ablation study on each module to understand, again, weaknesses and strengths of your module on your data, and also understand where most of the errors come from. Which is
Yeah.
something that you can't do when you just have one generic statistical model and you just throw data inside, you cross your fingers and hope that everything goes well.
Yes. Okay, thank you, Rick. And it was very nice interaction with you, and especially whole data and the presentation. I'll go
No
through
problem.
again once again. Was going through all the data within the short time. It's not possible. So I'll come back if I have some doubts with you.
Yes, please feel free to contact me anytime.
Okay, thank you.
ठीक है देना.
Hi, Asif.
Yeah,
You're
Eric, thank you
muted.
for all your time. Sorry, I could not attend few of your first half. Actually, I had a lecture, so I had missed
No,
it.
I mentioned
Yeah,
your name so many times.
yeah, I had it. I had
Yes,
it.
yes.
I said all the good papers that we published
Yeah.
together. I even mentioned some
Yeah.
of those, and you were not even listening.
No, 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 no. In the first time, I was not listening. Now I listen. Now I listen. Yeah. So in the last half an hour, I heard that all the good things that you have spoken. Thank you. So I joined at 12 actually. So until 12, I had a lecture. Okay.
Mhm.
So I think the participant, if you have any questions, so you can ask Professor Eric. Otherwise, maybe Eric, anything, any suggestions to the participants if you have any top level, let's say, uh, kind of, many of them may be interested to take up a specific research. Many of them, some of them may be for planning for doing a PhDs also. So
Mm.
few of them are doing the working in the industries, right? So they have the varieties of backgrounds, okay, and few of them are also linguists. I hope this has been useful for all of them. Uh,
Yeah,
see
so
any participant?
as
Yeah,
I
yeah.
said, it's important, first of all, to embrace the fact that AI is here and cannot be
Mm.
stopped, and in general is a positive force that we should try to learn as much as possible. Don't be scared about the technicalities of AI. It's also fine to, as I mentioned recently, just use some APIs or available tool, and as long as you know how to use it, interpret results, know what are its limitations, then it's also fine to be just a user of AI, like you drive a car without knowing how the car inside actually works. So the most important things are these two: the attitude towards AI, and then being able to use it and interpret the results. And then, if you are curious enough to go into the details, there are some links I provided in the slides to more details, but also it's important to choose a topic that you're particularly interested in. We were discussing yesterday, for example, if you look at this slide here, there are so many topics here that we are looking at to do natural language understanding, and each of these can be a PhD on its own. So it's important also to be focused enough to just select maybe one of these, one or two, and just focus on those. But in general, um, it's important also to identify a need. So if you realize that some of these topics, for example, are already kind of saturated, then maybe it's not a good idea to focus your research or your business on those. But if you see that there is still potential or like a user need that is not satisfied yet, then definitely that sounds like a good research or business direction. But anyway, if any of you has any other specific questions later on, again, feel free to get in touch and I can give you more specific links to the literature or things that could be useful for you. Okay, so if no more questions, then I'll say goodbye.
Yeah, I think Eric, thank you very much. I don't think they have any questions further. But we'll let you know the feedback and we'll coordinate with you. Yeah, okay, Eric. For the
Okay.
other official purposes, and they can reach out to you because in your slide, in your lectures, your email IDs are also mentioned. So I'll
Yeah.
request the participant, if you are writing to an email to Professor Eric, please give the reference of this GAN code, so that will be good to connect.
Yeah,
Yeah.
yeah. Thanks for mentioning that. It's important that when you connect with me, you specify that you were attending this workshop, because then I receive like countless emails and also like LinkedIn invitation. If I don't know who you are, I will not add you and I will not reply. So please clarify that you were one of the Gyan attendees so that I will make sure that I don't miss your email or your invitation to connect on LinkedIn or wherever else.
Yeah. Okay, so Eric, I think thank you. So maybe participants, I don't see they have any other specific questions. Yeah,
Okay, thank you very much.
thank you.
Hope next time we can meet in person. Are you
Yeah,
coming to
yeah, look
Singapore
forward.
anytime soon? There is ICLR next month. Are you coming?
Yeah, so I had a paper, but it is rejected anyway, so I cannot travel. But anyway, so yeah, last to 23rd MNLP, I went there. Yeah, probably I missed to meet you, but anyway, let's see, Eric.
Yeah,
So,
if
is there any plan to come to India now in recent time? No.
no plans yet. No plans of traveling for a while, but maybe next year.
Next year. Okay, I understand. Okay, Eric. See you then. Thank you.
Thank
Thank you.
you. Keep in touch. Bye bye. Thank you, everyone.
Thank you, sir. Bye bye.
Have you all a good weekend.
Thank you. Thank you.